Hello, Abysseites. Welcome to Calculus. Abyssians, or whatever you call yourselves out there. Really, you can wander anywhere you want to go into the abyss, and you decide to be here. Okay. All right. So, let me get you. I got quizzes to ask you. And so we will start with Jack. You ready? Okay. Last person I asked this question passed. Okay. Second period. So you can figure out who sits there. Here's number one. There's going to be a series of them. And this is live, you know. Okay. But you can pass if you choose. What's the answer to that? Almost. Very good. Raymond.
2x plus c.
Number three. Let's see.
One half e to the x plus c.
Did you say 2x?
Yes, I definitely did.
Okay, good. No, it pays to have a teacher that's extremely hard of hearing, doesn't it? Okay. Yeah, I said those things. Another thing I did not hear. Logan.
1 half e to the x squared plus c.
I don't think he does. Burger, do you mind counting for us?
What?
Do you mind counting for us?
That better?
Yeah, sure.
1, 2, 3, 3, 3. I mean, you just realize now I cannot count? That's an x cubed. And that's an x squared.
2x, 1/3
I heard 1/3, I heard e. Well, the exponent stays the same, correct? And this means this x cubed, it needs its derivative in the integral.
3x.
Right, so it would need a 3x squared, correct? So if I put a 3 there, I have it, except I just can't arbitrarily throw in a 3. I have to multiply by what else? 1/3, okay? So this now is the derivative of that, and it's gone because this is the antiderivative. So in other words, if I took the derivative of this, I'd have 1/3 e to the x cubed times the derivative of that exponent, which is 3x squared, and then that would simplify the 1. Correct?
Yeah.
Okay. Emily, I'm going to tell you what your answer should be. Well, I'll write it down. Your answer should be pass. Do you want to try to solve that, or do you want to pass? You think it's... I really think you should pass.
Pass.
Good choice. Riley, I think you should pass also. Okay. You know why? What's the derivative of x? 1. And x is not 1, is it? Correct? And Noel, you should probably Yeah, and Cooper, you'll try to figure it out.
What's gonna happen?
You're going to pass also. Okay? And Destiny, you're going to pass. So we're going to look at a method in which we're going to be able to figure that out. Okay? So what I'm trying to say is anytime I solve an integral, even when I had something as simple as this, and I think this is what I gave Jack, the derivative, when I just have this, the derivative of x exists in this integral, doesn't it? Did I give you that note? Did I give you a pass?
Yeah.
Okay. Times 1. Okay? Right? Because that 1 is in there. All right? But this is not the derivative of x, is it? It's something extra. So what I'm trying to say is you should always try to reverse the chain rule if you can. That's your first step. That should always be your first step. So we're going to take a look at a thing called integration by parts. And the idea of it is we're going to create parts to be able to solve this. Can you guys see this okay? All right, so let's say h, and you're okay if I just write h instead of h of x? Jack, are you okay with that? Okay. So here's h, and I'm going to say h is a function that's a product of two functions, f times g. And so we're going to take the derivative of this. And so we're going to have to, Manu, we're going to have to do the what rule? Yeah, it's up on the window. Starts with a P. It means multiple product rule. Okay, so what is the product rule?
F prime x times g prime.
F
F x
times
F times g prime plus F g prime F prime times g.
Okay, can I write it like this?
Yeah.
Okay. Everybody okay with that? And what I'm going to do now is I'm going to work my way backwards, and I'm going to take the antiderivative because we're trying to find a process in which we figure out an antiderivative. So that's why I'm doing it. So I'm going to take the antiderivative here. And if h prime is the derivative of h, that means the antiderivative of h prime is h, correct? And I can break this up as two separate integrals. And I think you're okay with that, right? Because I've done that before, especially when the integration techniques are different. And h is the same as f times g, isn't it? So I could substitute this in here. And what I'm going to do is I'm going to subtract this integral and bring it over. So I'm going to have f times g minus the integral of g times f prime, oops, I didn't want that thing there, is equal to the integral of f times g. So I want to, a lot of times I want to look at integration by parts is kind of reversing the product rule. And what I do is I take a look and I have two functions that are not related to each other. In other words, if I go back to this one where I have e the x squared times 2x dx, this function right here has a relationship with that function, correct? Because it's created from the chain rule. This 2x came from that. But when I had this problem, I don't have that relationship, do I? But I have two separate functions. I have I have x and I have e to the x, right? So what I'm going to do is I'm going to rewrite them so they look like this. I'm going to identify 1 to be f and take its derivative, because that's what I need right here. And I'm going to identify 1 as a derivative, and I'm going to find its antiderivative, which I have here. All right? So let's take a look at this first one. And so a lot of times, the reason I wrote option 1, option 2, is a lot of times people say, well, how do you decide which is which? And I'm going to give you some hints as we go along here. All right? So what I'm going to say is, I'm going to start out and I'm going to say that f is equal to x. And so I'm going to find its derivative, and that's going to be 1. So this is f right here. So that means ln, the natural log of x, is going to be g prime. It's going to be a derivative. And I have to find its antiderivative. So what's the antiderivative of the natural log of x? Jacob, do you know?
Is it 1 over x?
That's the derivative. What's the antiderivative? You want to know my answer for you?
Pass.
Don't know yet. Right? So we can't do that. So we're going to look at option 2. Well, what's option 2? Option 2 is that I make f equal the ln of x. And what did you say its derivative was, Jacob?
1 over x.
1 over x. That means I'm going to let the other function, which is x, be the derivative. And Cole, what's the antiderivative of x? 1/2 x squared. 1/2 x squared. So just as a reminder that the product rule says you're going to identify two functions that are being multiplied together. Let one be an antiderivative and the other one be a derivative. And then you're going to multiply f times g minus the integral of g times f prime. That's our process. So I always write them in this manner. You'll see me do this every single time. So f times g would be the product of those two. Would you agree? So it's going to be 1/2 x squared times the natural log of x minus the integral of f prime times g times those two. Jake, what is 1/2 x squared times 1 over x? 1/2. 1/2 x, right? Because this x simplifies with one of these x. Would you agree? Dx. Now notice I have not written c yet. I don't do it till the very end. So now, Nathan, all I have to do is figure out the antiderivative of this, which is a lot easier than what I started out with, correct? So I have 1/2 x squared ln of x minus what? 1/4 x squared plus c. Okay, I'm going to pause. Does everybody see where the 1/4 x squared comes from? Okay, now I can check by taking the derivative of this, correct? And it better look like this. Okay, so this I'm going to use the product rule. I'm going to have 1/2 x squared times the derivative of the ln of x, which is 1 over x, plus the ln of x times the derivative of this, which would be x, because 2 times 1/2 is 1. Subtract 1 from 2, get 1. And then I'm going to take the derivative of this. I'm going to have minus 1/2 x plus, oops, plus 0, right? Because the derivative of that is 0. Now, Cade,
Yep.
what is this?
That would be 1/2 x.
And over here I have a minus 1/2 x.
Yeah, so those would cancel out.
And I'm left with this,
Yes.
which is what I started with. Okay? All right? Can I move to the back side? Riley, you got a question? None? Okay. Destiny, you have a question.
How do I have x's cancel out?
Oh, because this could simplify here to 1/2 x, because that's over 1 and that x simplifies with one of those x.
Yeah, I see that.
Okay? And then right here I got a minus 1/2 x. I just moved it over here, plus x ln of x. Okay? All right, everybody see that?
So what's the answer? Ln x squared.
This is your answer right here. That's the antiderivative of this. Okay? All right, now, there are some functions that I say decompose. I'll give you an example. Let's say I have x cubed, and I take its derivative. It becomes 3x squared, correct? And I take that derivative. It becomes 6x, correct? And if I take that derivative, I get 6. And if I take that derivative, I get 0, right? That I call that decomposition. However, if I take the derivative of e to the x, I get e to the x, e to the x, e to the x. Likewise, if I take the derivative of sine, I get cosine. And if I take the derivative of that, I get negative sine, correct? And if I take the derivative of that, I get negative cosine. And if I take the derivative of that, I get sine. Those two functions do not decompose, do they? All right? All polynomials will decompose. And the reason I do that is I want to make sure I solve this. I'm going to let f be x because I know its derivative is 1. And over here I'm going to have g prime. Remember, the other function has to be the derivative, and I get e to the x, and the antiderivative is e to the x. So I chose this to be f because when I take its derivative, it decomposes and gets simpler. If I would have made it an integral, it would have become 1/2 x squared, correct? And becomes more complex. Does that kind of make sense? So now my answer is going to be x, e to the x, these two. Again, up here I'm going to write down that if I have f times g prime, I'm going to get f times g minus the integral of f prime times g. So now I'm going to multiply these two, and I'm going to subtract e to the x. So my answer is x e to the x minus the antiderivative of e to the x is e to the x plus c. Again, this is the antiderivative. I can check by taking the derivative. Again, I have the product rule. And do you see how these cancel out? And I'm back where I started. Zach Sawicki, number 3. Which one do you think should be F?
X squared.
Okay. Okay, that's what you would have me do?
Maybe.
Okay. What's the derivative of f?
2x.
Okay. What's the antiderivative of the ln of x?
Okay, got mine.
Okay. So what do you want f to be here?
Ln of x.
ln of x. What's the derivative of f?
1 over x.
Over here, g prime is equal to x squared. What's the antiderivative of x squared?
1/3 x to the third.
1/3 x to the third. Perfect, okay? So what's the first thing I'm going to write as an answer?
F times g.
Yep, what is f times g? I agree with that 100%.
Ln of x times 1/3 x to the third.
Yeah, can I write it like this? Is that okay with you? Okay. Minus what?
X squared times 1 over x.
Well, I'm going to integrate, correct?
Oh, yeah.
Okay, and I get 1/3, correct?
Yeah.
And what else?
Oh, 1 over x.
Yeah, I get 1 over x times x to the third, correct? What is that?
X squared.
X squared. So I have 1/3 x to the third ln of x minus, what's the antiderivative of this?
1/9.
Yes. 1/9 x to the what?
Third.
Plus
C.
c, perfect. So when you have the ln of x, you're going to make that f every single time, okay? All right, so Logan, what's f going to be?
ln of x.
Perfect. What's the derivative?
1 over x.
1 over x. So once I replace, what's the ln of x being times by?
1.
1. So I could say g prime is 1. So what is g?
X.
X. All right, you okay with that?
Yep.
Okay, so tell me what to write.
Ln of x times x.
Can I write that x ln of x?
Yep.
Okay. Otherwise, to me, it looks like x times x, and I have a chance to write x squared. And, okay, minus what?
Minus 1 over x times x.
Yeah, the integral of 1 over x times x. What is 1 over x times x?
1.
1. So my answer is x ln of x. What is the antiderivative of 1?
X.
Minus x plus c. So that is the antiderivative of the ln of x.
Yeah.
Okay. Tiffany, number 5. What are you going to let f be?
Either x.
Okay, you can. Okay. And then then you would make g prime x squared.
Yeah.
Okay. And then what would be the antiderivative of x squared?
1/3 x to the third.
Correct. It got more complicated, didn't it?
Yeah.
Okay. So in this case, can you take the antiderivative of e to the x? Okay. Whereas before, taking the antiderivative of the ln of x was difficult to do. Correct? Okay. So I'm going to have f be x squared because I know it'll decompose. Most of the time I do that except for the ln of x. Because the ln of x gives me 1 over x, and when I multiply it by a polynomial, it gets rid of that one of those. It reduces the exponent. Okay. So what's the derivative here?
2x.
So g prime is e to the x. Would you agree?
Yep.
What's g?
Either x.
E to the x. Okay, so how am I starting this then?
X squared times e to the x.
Yeah? Minus what?
Integral of e to the x times 2x.
Yeah, and I'm going to write it like this. Are you okay with that?
Yeah.
Okay. Now again, the derivative of x is not 2 to the x, is it? Or the derivative of x is not 2x, correct?
Right.
So that means I'm going to do it all over again, one more time.
Okay.
All right? So f this time is going to be 2x. And f prime will be what?
Just X or 2.
2. And so g prime is equal to e to the x. G is going to be what?
E to the X.
E to the x. So I'm going to write it up here. I have x squared e to the x minus parentheses f times g, which is 2x e to the x minus what? The integral of what?
Would be this 2
2.
to the X.
Yep, 2 e to the x. So this is going to give me x squared e to the x minus 2x e to the x. What's the antiderivative of this?
I don't know.
Okay, what's the antiderivative of e to the x?
E to the X.
So if it's 2, if I'm multiplying by 2, it's just going to be 2 e to the x. So this is a negative, this is a negative, it's going to be plus 2 e to the x plus c. Notice how I started with x squared, it decomposed to 2x, it decomposed to 2. There's a pattern there, isn't there? And that I have e to the x in every single one, correct? Will that always happen? Yep.
So it'd be positive. Never mind. Well, does it always go then positive, negative, positive as you go down?
Yeah, if
So
f
it's
if
like-
f starts out positive, yeah.
Alright.
Okay. So if I gave you this, I'm going to let x cubed be f. Would you agree? So I'm going to have x cubed e to the x minus 3x squared e to the x plus 6x e to the x minus 6 e to the x plus c. Okay, see where I got these terms? Okay. Jack, what do you know about e to the x and the sine of x? What do they have similar? Pardon? What don't they do? Not sure? Raymond, what can you tell me about e to the x and the sine of x? Pardon? Yeah, they never end up being 0, do they? This always stays e to the x, and this eventually comes back to the sine of x, doesn't it? Okay? So what's going to happen is I'm going to keep following the process till I get back to this answer. Okay? You keep going until you get back to e to the x sine of x. Now, it does not matter which one's f and which one's g prime. I have a personal feeling on it because I have no problem taking the derivative of sine, then the derivative of cosine, and then the derivative, keep taking the derivative. However, I always screw up when I take the antiderivative of sine. Sometimes I forget it's negative cosine. And you have to decide, if you're not that person, that's fine. It doesn't matter. So what I always do is I let f equal the sine of x. So that means f prime is going to be the cosine of x. G prime will be e to the x, and g will be e to the x. So I'm going to start out with f times g, which is e to the x, the sine of x, minus e to the x cosine x dx. Then again, I'm going to let f equal cosine x. That means f prime is equal to negative sine x. Again, g prime is equal to e to the x. G is equal to e to the x. So that gives me e to the x sine of x minus parentheses e to the x cosine of x minus e to the x times negative sine of x dx. Parentheses. So now I'm going to distribute. Now notice I have a negative here, a negative here, and a negative here. So that's going to give me a negative e to the x sine of x. And there's an integral symbol in front of it. Notice I'm trying to get, I'm back here, I'm back to where I started, right? If I don't stop here, it's going to keep on going. I'm stopping right here and saying this is what I'm trying to find out. So now I'm going to move this over to here. So I have e to the x sine of x minus e to the x cosine of x is equal to the integral of e to the x sine of x dx plus the integral of e to the x sine of x dx. I got two of them, don't I? The integral of e to the x sine of the x plus e to the x sine of x. I got two of them. So I could write it like this. And it's equal e to the x sine of x minus e to the x cosine of x. So all I got to do is divide by 2. And I have e to the x sine of x minus e to the x cosine x divided by 2, and that's equal to my integral of e to the x sine x dx. And that's it. So you have how much time now? 25 minutes? I would start some of these for sure, so you get a hang of them. And I'll talk about L'Hopital's rule tomorrow.
I didn't get the last bit of that because my eyes actually
like kind of have a hard time seeing.
Oh, really? You could have moved right up to here.
Yeah, I probably should have, but for now, can I just jot that down? I'll sit over there. Thank you.